Alright, so this is just a quick recap of Pythagorean theorem and slope. Considering that we've learned this before, we're just going to kind of zoom through this, and this will be a short lesson for tonight. Just as a refresher, this is Pythagorean's theorem. It's one of the sides squared plus the other side squared is equal to the hypotenuse squared. Just remember that the hypotenuse is the one that's across from 90 degrees. Alright, so a Pythagorean triple is when we have three perfect integers. They're going to be positive because the distance cannot be negative. So if all of these are just like integers, not decimals, not radicals, they're integers, then we will have a Pythagorean triple. So I'm going to do the Pythagorean theorem here. I am missing the hypotenuse, so I have 8 squared plus 7 squared equals c squared. I get 64 plus 49 equals c squared. So I get 113 equals c squared. To get rid of the square, use square root. And c equals the square root of 113. So this side right here is the square root of 113. The square root of 113 is not an integer, so this is not a Pythagorean triple. It's not a pretty one. Okay? Alright, over here, this time I have the hypotenuse, so I'm missing one of the sides here. So I will do a squared plus 21 squared equals 24 squared. Okay, I get a squared plus 441 is equal to 576. I will subtract 441 from both sides. A squared equals 135. A equals the square root of 135, which simplifies to 3 square roots of 15. Because this is not a integer, this is not a Pythagorean triple. Alright, so I'd like to go ahead and take a minute and look at D. Okay, I have the sides, I'm missing the hypotenuse. So 5 squared plus 12 squared equals c squared. So 25 plus 144, that's going to give me 169. The square root of 169 is 13. So since all three sides are integers, this is what we could call a Pythagorean triple. Alright. Alright, now on letter C, we can actually take a shortcut. Okay, first off, this right here is not an integer, it's a decimal. So we can go ahead and say this is not a Pythagorean triple. However, they do want us to go ahead and find the missing side. So the side that I circled is the hypotenuse. So I get a squared, plus 25 is equal to 50.41 minus 25 from both sides. Square root both sides to get a is approximately 5.04. Okay, so we obviously know this is not a Pythagorean triple. I'm getting decimals and not integers. Alright, now the converse is also true. Okay, if the Pythagorean theorem works, then this is going to be a right triangle. The biggest catch here is that people need to remember the hypotenuse is the longest side. So looking at this, I would think that 15 would be my hypotenuse. It has to be, if this is a right triangle. So what we're going to do is we're going to see is 9 squared plus 12 squared equal to 15 squared. So I get 225 on this side, 81 and 144 here. So that does add up 225 for both sides. So since this is true, this is a right triangle. Alright, the largest side here is 17.4. So 17.4 squared equals 10 squared plus 14.2 squared. So that's 302.76 is equal to 301.64. This does not work. Oh, 301, excuse me, 301.64. That doesn't work, so it's not a right triangle. Alright, why don't you pause and try C, and we will confer and see if you got this. Alright, so as you can see here, 129.96 is not equal to 80, therefore this is not a right triangle. Alright, triangle ABC, C is the longest side. This is the Pythagorean inequalities theorem. If C squared is larger than A squared plus B squared, then it's an obtuse triangle. If C squared is less than A squared plus B squared, it is an acute triangle. Alright, so we need to figure out, is this a right triangle, meaning that C squared is equal to A squared plus B squared, or is it acute, meaning that C squared is less than, or obtuse if C squared is larger. Alright, so I have 8, 11, 13. 13 is my largest, so it would be my hypotenuse. 13 squared is 169. 8 squared plus 11 squared is 185. Since C squared is less than 185, that would be an acute triangle. Alright, so take a minute and solve this problem. Go ahead and pause the video, and then we can re-click it and get it going to see if you got it correct. So the largest side here is 16, so I would do 16 squared equals 7 squared plus 12 squared. 16 squared is 256. 7 squared plus 12 squared is 193. So C squared is actually going to be larger than A squared plus B squared, so this is an obtuse triangle. Alright, so that's it for Pythagorean theorem. We're going to move on to slope at this point. Remember that slope is rise over run. If you don't remember this formula, you need to jot it down and memorize it. It is not given to you on your formula sheet. Alright, so slopes can have different values. So we can have positive value, meaning we're growing. So you always read it from left to right. Going up, going down is negative. Going left to right, if there's no change, that's 0. And if I can't move left to right at all, that's what we call undefined. You need to be able to match a graph of different lines to see, hey, what kind of slope do I have going on here? So let's go ahead and use the slope formula. Okay, this is x1, this is y1, this is x2, this is y2. So the slope here will be 7 minus 2 over 6 minus 5, which is 5 over 1. So the slope here is 5. What I'd like for you to do is go ahead and pause and work on problem B and see how you do. Alright, so showing my work here, you can see that I have found the slope to be -3. And that is the slope for that problem. That's really all we have for slope. There's not much going on there. So, like I said, short and sweet. I will see you guys later.